class 11th. Today we will study a simple topic, that is the electrovalent bond. What is electrovalent bond? We call it ionic bond. Electrovalent bond, the bond formed as a result of complete transfer of electrons. As a result of complete transference of electrons from between two or more atoms. There occurs complete transference of electrons from one atom to the other atoms. It occurs between two or more atoms, so as to attain the stable configuration of nearest inner gas. Is known as electrovalent bond. The bond formed as a result of complete transference of electrons between the two or more atoms, so as the atoms attain the stable configuration of the nearest inner gas, is known as electrovalent bond. This bond is also known as ionic bond, or we call it's a polar bond also. We call it a polar bond. The transference of electrons results in the formation of cation and anion, the two oppositely charged ions. The oppositely charged ions are held together by electrostatic force of attraction. Force of attraction. For example, if we take the potassium chloride, an ionic compound, potassium chloride, KCl, in potassium, it has atomic number 19, and configuration we write, if we write it simple, it is 2:8:1, 8:2:8:8:1, or we write it has one electron in the outermost shell, that is 4s. In the 4s shell, outermost shell, valency shell is s, fourth s, it has one electron. So I will show this electron in the Lewis dot and cross as a cross. By Lewis dot we represent the electrons, outer valence electrons, by Lewis dot and cross structure. So it has, I have shown this electron as cross. Now if you take the case of chlorine, it is atomic number is 17. It has, I will write the configuration here. It has 5 electrons in the outermost shell, which has p shell, 3p5. Outermost shell is 3p5. So I will show these 5 electrons on chlorine in form of dot. There are 5 electrons, 1 2 3 4 5. Now one electron from the potassium gets transferred to the chlorine. As a result, potassium forms potassium cation and chlorine forms chloride anion. Now there are positive and negative charges. These two oppositely charges are held together by the electrostatic force of attraction. So a potassium chloride molecule is formed. This bond is because here transference of electrons takes from potassium, and which is gets transferred to the chlorine. As a result, chlorine potassium forms cation, potassium ion cation, and this forms chloride ion, so anion. These two oppositely charged ions are held together by the electrostatic force of attraction. Similarly, if we take the formation of sodium sulfide, sodium, it has, I will write its configuration. The one electron is present in the 3s level, or I simply we write it is 2 is to 8 is to 1. It has 11 electrons. One electron is present in the outermost. I will show that electron by means of a cross structure. And sulfur has 16 electrons, so 3p, it has 4 electrons in the outermost shell. Now, since sodium atom has 1 electron, and it has to lose its 1 electron to gain the nearest configuration of neon, which is equal to 10, which is 10 atomic number. And sulfur, it has 16 electrons, it has to gain 2 electrons so as to get the nearest configuration of argon. So 2 sodium atoms combine with single sulfur atom. That means 1 electron from one sodium and 1 electron from another sodium. 2 electrons each from 2 sodium atoms, they get transferred to the sulfur. As a result, sulfur forms sulfur dinegative sulfide, and sodium, since there are two Na2 and positive, I have shown the positive here. Two sodium atoms lose the 2 electrons, and I have shown here and this Na2 positive ion and sulfur dinegative ion, and these two oppositely charged ions are held together by the electrostatic force of attraction, and this is the formation of the ionic bond or the electrovalent bond. Now, students, here in the formation of ionic bond, the atoms, one atom loses electron and other atom gains the electron, other atom gains the same electron. If one atom loses the one electron, other gains the same, there takes the loss, one atom loses the electron. And if we take the oxidation reduction concept, then the atom which loses the electron gets oxidized and the atom which gains the electron gets reduced. Now, in this formation of bond, number of electrons lost, अगर कोई एटम कितने इलेक्ट्रॉन लॉस्ट करता है और गेन करता है इन द फॉर्मेशन ऑफ इलेक्ट्रोवैलेंट बॉन्ड is called electrovalency. So electrovalency is defined as the number of electrons gained or lost by an atom during the formation of electrovalent bond, that is known as electrovalency. For example, in potassium chloride, potassium loses the 1 electron, so electrovalency 1, and chlorine gains the electron, here it is -1. So number of electrons gained or lost during the formation of electrovalent bond or ionic bond is known as electrovalency. Now, students, this electrostatic field is non-directional. That is, each ion is attracts number of oppositely charged ions. That is, cation attracts a number of anions. That depends upon the size of atom and the radius of atom. That depends upon the size, atomic size and atomic radius. Now similarly we can say a cation attracts a number of anions. Similarly we can say an anion attracts a number of cations. Now as a result of a three-dimensional structure, or we can say an ionic crystal is formed. An ionic crystal is formed when an cation attracts the number of anions, and an anion attracts the number of cations, which depends upon the atomic radius of cation and anion respectively. So in this case a three-dimensional structure is formed, that is called the ionic crystal. Now number of ions which surround a given ion is called coordination number. For example, number of ions which surround an opposite charge ion is called a coordination number. For example, sodium is positive charge and it is surrounded by 6 chloride ions. So coordination number of sodium in this case is 6. Similarly, in sodium chloride we say sodium chloride mein coordination number is 6. Similarly, in cesium chloride coordination number is 8. So number of ions which surround a given oppositely charged ion is known as coordination number. Now students, since the ionic bond is formed by the complete transference of electrons from one atom to the other atom, there are a number of conditions which favor the formation of an electrovalent bond. First condition is number of valence electrons. Students, you know that this bond is formed by the transference of electrons from one atom. The atom that loses electron is surplus of those electrons than the nearest inert gas configuration. Similarly, the atom that gains electron is deficient of those electrons. It gains to attain the nearest inert gas configuration. That means the atom that loses electron is surplus of the electrons which it loses. It loses those electrons to attain the nearest inert gas configuration. Similarly, the atom that gains electron is the deficient of those electrons which it gains, and it gains those electrons to attain the nearest inert gas configuration. Now, for example, the atom which loses electron must have 1, 2 or 3 electrons in the valence shell. That is, the atom which loses electron, it is electropositive. It loses the electron. For example, in first group, that is sodium, potassium, rubidium, cesium, and second group, magnesium, alkali metals and alkaline earth metals. These have 1 electron in the outermost shell and these have 2 electrons in the outermost shell. Similarly, aluminum, it has 3 electrons in the outermost. So they have the 1. That means the atom that loses electron must have 1, 2 or 3 electrons in the valence shell. It loses 1, 2 or 3 electrons. These electrons are actually surplus than the nearest inert gas configuration.